Hello, our first problem will be to prove that this number, this real number, lies within this interval. How do we do that? So our first approach will be, approach first, lies within this intervals means that this number, square root of 3 divided by square root of 5 to the power of square root of 7 is more than 2, but at the same time, it is less than 3. So let's write it. Okay, to cancel out some square roots, we can raise both sides to the power of 2. So we do that. And then we have, from the algebraic identities, I mean a plus b squared, it is a squared plus 2ab plus b squared, right? So from that we have 2 plus 2 times square root of 2 times square root of 3 is square root of 6 plus 3 divided by 5 to the power of square root of 7 is more than 4. I used here the fact that we can shuffle powers, right? So a to the power of b to the power of c is the same as a to the power of c to the power of b. And the same here, right? Let's compute it further. So we have 5 plus 2 square root of 6 divided by 5 to the power of square root of 7 is more than 4. We can write it like this, and it is the same on this side. But less than 9. And now let's prove the first inequality, so this one. We have 5 plus 2 square root of 6 divided by 5 to the power of square root of 7. We know that square root of 6 is more than square root of 4, which is 2, and square root of 7 is more than square root of 6.25, which is 2.5. So we can write that this thing is more than 5 plus 4 divided by 5 to the power of 2.5. So it is 9 over 5 to the power 2 times square root of 9 over 5. It is 81 divided by 25 times 3 square root of 5 divided by 5. It is 233 square root of 5 divided by 125. And what we need to prove is that this thing is more than 4, so more than 500 over 125, because this is 4, right? So the only thing is to prove that 243 times square root of 5 is more than 500. Let's prove that. We know that 5 is more than 2.2, because 2.2 times 2.2 is not 4. 2.2 times 2.2 is 22 times 22, so it is 484, so it is 484. So square root of 5 is more than 2.2. So this thing is more than 233 times 2.2 divided by 125, and indeed 233 times 2.2 gives us 6, 8, 4, 6, 8, 4, 6, 4, one more, 5 plus 8 is 3, and now here 5, and we have dot here. So it is 534.6 over 125, and it is more than 500 divided by 125. Okay, that means that this thing is more than 4, so this inequality holds. All numbers here are positive, so this inequality holds as well. We have a second inequality, this one, and this one is simpler, so let's solve that. We know that square root of 7 is less than square root of 9, which is 3, and square root of 6 is less than square root of 6.25, so it is less than 2.5. So now we can write 5 plus 2 square root of 6 divided by 5 to the power of square root of 7 is less than 5 plus 2 times 2.5 divided by 5 to the power of 3, which is, here is 5, so it is 10 over 5, which is 2 to the power of 3, which is 8. So indeed it is less than 9. And because this inequality holds, this one holds, and this one holds. And that's what was to be proven. But this is the first approach, maybe not the best one. Let's see another. Let's put a line here. And now, from the inequalities between the mean, quadratic, arithmetic, and geometric, so from the inequalities between the means, quadratic, or root mean, it is the same. It has two names, arithmetic and geometric. We have quadratic mean is always more or equal than arithmetic mean, and it is always more or equal geometric mean. Let's go here, and let's recall what those quadratic mean, arithmetic mean, and geometric mean means. So for the two values a and b, we have quadratic mean, it is square root of a squared plus b squared divided by 2. Arithmetic mean is a plus b divided by 2. And geometric mean means square root of a times b. For our case, let's a be square root of 2 and b be square root of 3. Then we have square root of 2 to the power of 2 plus square root of 3 to the power of 2 divided by 2 is more or equal, but equal is only when a and b are equal, but they are not. So it is more than square root of 2 plus square root of 3 divided by 2. And it is more than square root of 2 times square root of 3. So let's compute some things here. It is 2 plus 3, so it is 5 divided by 2. It is more than square root of 2 plus square root of 3 divided by 2. And it is more than square root of 6, which is, at the same time, fourth root of 6. Right? We can multiply by 2 all the sides. Then we have, in the middle, it is square root of 2 plus square root of 3. Here, 2, it is the same as square root of 4, so it is 4 times 5 over 2. And it is more than 2 fourth root of 6. We can write that this thing in the middle is as it is, but here we have square root of 10, and here we have 2 inside this square root is 16, right? Fourth root of 16 is 2, so we have fourth root of 96. Now what we want, let's go up, is square root of 2 plus square root of 3 divided by square root of 5, right? So we can divide both sides by square root of 5. Square root of 5. Then we have what we want to have, this thing that we want to calculate an approximation. So this is more than, here we can write fourth root of 96 divided by 25, because square root of 5 is fourth root of 25. And here we have square root of 10 divided by square root of 5 is square root of 2. And now let's raise everything to the power of square root of 7. And then we will have our number divided by square root of 5 to the square root of 7 is more than this thing, but it is less than square root of 2 to the power of square root of 7. We need to prove that this part, square root of 2 to the power of square root of 7, is less than 3, and this part, this one, is more than 2. Because if this part is more than 2, then our number is more than this number that is more than 2, so it is more than 2. And if this number is less than 3, then our number is less than this number that is less than 3. So let's do that. Square root of 2 to the power of square root of 7 is less than square root of 2 to the power 3, because 3 is bigger than square root of 7, which is square root of 8, which is less than square root of 9, which is 3. So we proved the first inequality. The second one is more complicated, but let's try to do it. So we have fourth root of 96 divided by 25 to the power of square root of 7. Oh, I should write this here. This more than fourth root 96 divided by 25 to the power of 2.5, right? Which is 5 divided by 2, so we can write that this is 8th root of 96 divided by 25 to the power of 5, which is more than the same thing, but 90. Let's take 90 because it is easy to cancel out. So we cancel out those things. Then we have that this is 8th root of 3.6 to the power of 5. And we need to prove that this is more than 2. More than 2 means that this is more than 8th root of 256. Right? So we only need to prove that 3.6 to the power of 5 is more than 256. And this is quite easy because 3 to the power of 5 is almost 256, it is 233, so we can write that 3.6 to the power of 5 is more than 3.6 times 3 to the power of 4. This is 3.6 times 81, and in fact 81 times 36 we have 6, 38, 3, 24, which is 6, 1 more, 9, 2. So when the dot is here, so it is 291.6. So it is really the fact that this thing is more than 256. So we have that this is more than 8th power of 256, which is 2. Okay, both proofs are quite complicated. We can think about one more approach, but it is also complicated. Let's see it. Approach 3. We have square root of 2, square root of 3 divided by square root of 5 to the power of square root of 7 is equal to square root of 10 plus square root of 15 divided by 5. I multiplied the whole this number by the fraction square root of 5 divided by square root of 5. So I did something like this to the power square root of 7. And we could use the simple calculator. If only simple calculator is what we have, then it is approx 32 divided by 10 plus 39 divided by 10 divided by 5 to the power of 27 divided by 10. And then we could write that this number is between 35 divided by 10 plus 30 divided by 10 divided by 5. I increased those values and I will increase this one as well. So it is 36 divided by 16, which is 3 divided by 2 to this power, or 16th root of 3 divided by 2 to the power 33. And this number is computable via simple calculator because we put 1.5, raise it to the power 33. So 33 times we need to multiply this thing, ignore some digits after the dot, and then compute square root, square root, square root, and square root, right? So it is possible to done on the simple calculator, which is available on some Olympiads, and it is more than. Now we need to put smaller numbers than those. So it is more than 30 divided by 10 plus 38 divided by 10 divided by 5 to the power of 21 divided by 8, which is 29 divided by 25, 8th root to the power of 21. And again, we can write this number, raise it 21 times on the calculator, ignore some digits after point, and then compute square root of this number 3 times square root, and square root. It is 8th root. And in fact, I did it. So I got that this is around 297, and this is around 224. So indeed, this is between 2 and 3. But of course, I don't like this approach because we need to use calculator. If we can use the calculator, we could use a computer to just calculate it. If you have another solution for this problem, let me know in the comments. And if you think that this problem was pretty easy, you can solve the harder version of it. I will leave it here and see you in the next one. Bye.